All right, as part of the warm-up, I want to review simplifying polynomial expressions. We learned about this last week, and I know this is a topic that gave us a bit of a challenge. So again, when you are simplifying exponents of polynomials, you are dividing the coefficients, subtracting the exponents in division, you are distributing the powers. So for example number 1 over here, you're going to take 12 divided by 2 to get 6. It's x to the 4th over x, so it's top minus bottom, so it's 4 minus 1, which is 3. And then again, y to the 2nd over y to the 5th, top minus bottom, so it's y cubed. So that gives you 6x cubed over y cubed. Again, the y is in the denominator because the 5 is larger than the 2. So when you do 2 minus 5, you get negative 3. Negative 3 tells me that the exponent drops down. For the middle example, we are going to distribute that cubed to every term. So it's going to look like 2 cubed, a squared times 3, because a power to a power is multiplied, over 3 cubed b cubed. Then we're just simply going to simplify that. 2 cubed is 8. A 2 times 3 gives you a to the 6th. 3 cubed is 27, and b cubed stays b cubed. A and b are not like terms, so we cannot simplify any further. In example 3, you're going to distribute the cubed to all 3 terms, giving you 6 cubed g 5 times 3. Again, power to a power is multiplied. H to the negative 4 times 3, giving you 216 g to the 15th h to the negative 12. Negative exponents drop to the denominators as positive, giving you 216 g to the 15th all over h to the 12th. The second thing we did was combine like terms with addition and subtraction. So here we have to distribute the negative to all those terms. So you get x squared minus 5x plus 2 minus 3x squared minus x plus 1. And then we're going to combine like terms, giving me negative 2x squared minus 6x plus 3. And in the second example, it's a positive, so you're just going to group the like terms together. So it gives you 9a minus 2b. And down here, is it a polynomial? If yes, state the degree. So here we have 3x plus 4y. Yes, that is, and that is degree 1 because both are linear. So that's a linear polynomial. And the second one, you have 1/2 x squared minus 7y. This is also a polynomial. And then in the last one over here, we have x squared plus the square root of x. A square root is not a polynomial, therefore it is no. What we're doing today is multiplying, and we're going to multiply monomials with polynomials. So first thing we're going to do is just multiply 2 monomials together. So we have 7x cubed times 3x to the 9th. Those are both monomials, so you multiply the coefficients together, so you get 21. You multiply the variables together, and when you multiply 2 variables to exponents, you add them. So you get 21x3 plus 9, which gives you 21x to the 12th. Here we have a monomial times a trinomial. So what we're going to do is distribute that first term to every term inside. So that's going to look like that 3x going to the 2x squared, the negative 4x, and the positive 6. So that is going to simply look like 6x cubed minus 12x squared plus 18x. There's nothing to combine, so we move on. Once again, we are going to distribute that first term to the next three terms. So that looks like 24x to the fourth all over 3 plus 36x cubed all over 3 minus 48x squared all over 3. And then the last thing we need to do is simply simplify, because 24 divides by 3, so does 36, and so does 48. So we get 8x to the fourth plus 12x cubed minus 16x squared. And then in the last example, this example is more of what you're going to see probably on an SAT, where it says a rectangle has a height of 3b squared and a width of 4b squared plus 2b minus 6. Express the area of the rectangle in standard form as a polynomial. So really, this is kind of like saying, okay, we have 3 rectangles, and we're going to add up all of the rectangles to get one big rectangle, where each piece of the width and height represent each other. So if you think about area of a rectangle, it is height times width. So what we're going to do is multiply the height and width of each of those 3 pieces. So it would look like 3b squared times all 3 pieces, which would look like 12b to the 6th So you have 12b to the 4th plus 6b cubed minus 18b squared. So again, you multiply the coefficients and you add the exponents. Now what you're going to do is go complete the practice problems on Khan Academy. Thank you.